Alright, hello pre-calculus students. So today we're going over the Unit 2 practice test for just polynomials. So just make sure you write down your name, your block, and your seat number. So block 1, 2, or 3, date, and your seat number. Alright. Now we're going to go to 1 where you just need to find the degree and the leading coefficient. So here the highest degree is our t cubed term. So our degree is 3 because that 3 is the highest value, and the leading coefficient is -8. So if we wanted to, we could rewrite this polynomial as -8 t cubed plus 9t squared minus 5t plus 7. Alright? Now, that's problem 1. Let's go to problem 2. For problem 2, we can simplify 4 minus 8x times 4x squared plus x minus 7 minus x minus 9x cubed. So, what we do here, let me adjust my chair a little bit. What we do here is we have to multiply 4 by all the terms in this trinomial and -8x by all the terms in the trinomial. That's how we start out. So 4 times 4x squared is 16x squared. 4 times x is 4x, positive 4x, and 4 times -7, well, 4 times -7 is -28. Alright, now we do -8x times 4x squared. Well, -8 times 4 is -32. X times x squared is x cubed. So we have -32x cubed. -8x times x is just -8x squared. Minus 8x squared. -8x times -7 is going to be positive 56x plus 56x, because 7 times 8 is 56. Alright, so before I go on to the minus x minus 9x cubed, I'm going to simplify that. So I still have -32x cubed. 16x squared minus 8x squared is just plus 8x squared. And then 4x plus 56x is just going to be plus 60x. And that's going to be minus x, and then so it'll be, oh, and sorry, plus 60x minus 28. So I didn't want to leave off the 28, and that's going to be minus x. That's one term we'll have to simplify into it, and then plus 9x cubed. Okay? So adding the 9x cubed, -32x cubed plus 9x cubed is going to be -30x cubed plus 7, which is going to be -23x cubed. So we'll have -23x cubed plus 8x squared. Alright, and then we have 60x minus x, which is going to be plus 59x minus 28. Alright, and we can leave that as our answer. I don't think that's factorable. Alright, let's go to number 3. Let me move around the paper and keep things zoomed in. Alright, factor each completely. So 75a squared minus 108. So this is one thing you have to know, is that 75 divided by 3 is 25, and 108 divided by 3 is 36. So I can factor out a 3 and get 25a squared minus 36. And so this is in the form a squared minus b squared. So I can write this as 3 times, and a squared minus b squared becomes a plus b, a minus b. So this becomes 3 times 5a plus 6, 5a minus 6. Alright, and that's completely factored. So square root of 25a squared is 5a plus 6, 5a minus 6. So 5a is the square root of 25a squared, and 6 is the square root of 36. So once again, that's 3 times 5a plus 6, 5a minus 6. I'll box that so we know that's our answer. Okay. And number 4, we have 6x squared minus 37xy plus 45y squared. So this one's a little bit tricky, but we got to know that really the only way to break down 6x squared to find those factors, it's either going to be 3x and 2x or 6x and 1x. But 3x and 2x are the most plausible when we're trying to get things that would add to 37, because 6 and 1 is more clunky. So once again, there's not a process that I did to find it out. That's just an intuitive function sense that I've developed. Hopefully you will develop soon. So I'm going to start out with 3x and 2x, because those will multiply to make 6x squared. And I need to find two numbers that multiply to 45y squared. And what if I had, and I also want to note something, that negative 37 is negative, so in order to make that middle term work, I'm probably going to need two negative numbers to get to that 45y squared, because that way the two negative numbers would add up to negative 37, because these two numbers right here need to multiply by 2 and 3 respectively and add to 37. So if we do 2x should be 2x minus 9 and 3x minus 5. If we do 2x minus 9y and 3x minus 5y, so that should be the factored, but let's double check. The reason why I did negative 9y, negative 5y, because negative 9 times negative 5 is 45, and y times y is y squared. Now why did I do that? Because if I have intuitive understanding of multiplication tables, I know that negative 9 times 3 is negative 27, and negative 5 times 2 is negative 10, so negative 27 plus negative 10 is negative 37. So let's break that down. 3x times 2x is 6x squared. 3x times negative 9y is negative 27xy. Negative 5y times 2x is going to be negative 10xy. And then negative 5y times negative 9y is going to be plus 45y squared. So once again, this will simplify to 6x squared minus 37xy plus 45y squared. So this is it factored correctly. Alright. Negative x to the fourth minus 12x squared minus 32. So to make this easier, I'm going to factor out a negative 1. So if I factor out a negative 1, I can have x to the fourth plus 12x squared minus 32, and this takes the quadratic form. So how can I factor x to the fourth power? Well, I can multiply that by x squared and x squared. Okay, and I need to find values that add to negative 32. And, oh, I'm sorry, if I factor out that negative 1, that would be plus 32. So if I factor out that negative 1, that changes the sign to positive 32. So we need values that add to multiply to 32 and add to 12. Okay? So that's going to ultimately be positive 8 and positive 4, because 8 times 4 is 32 and 8 plus 4 is 12. So this isn't a quadratic function, but it's in the form of a quadratic function, where the middle term has a degree that's 1/2 of the leading term, and then you have a constant at the end. Okay, so that's, we box the answer. That's number 5. For number 6, we have x cubed plus 4x squared equals 38x. So in order to solve this one, I need to get everything on one side, so we'll have x cubed plus 4x squared minus 38x is going to be equal to 0. And I can factor out an x, so if I factor out an x, because there's x is the greatest common factor, I'll have x squared plus 4x minus 38. And at this point, I can't really factor this, because there's no real values that multiply to negative 38 and add to 4. Because 38, that's going to be 19. There's no 19 and 2. It's either 38 and 1 and 19, or 19 and 2, and that's not going to combine to make 4. So you have to use the quadratic formula. The quadratic formula is, just reminder, negative b plus or minus the square root of b squared minus 4ac all over 2a. Is it negative b plus or minus the square root of b squared minus 4ac all over 2a? Yeah, I'm not going to quit my day job to sing anytime soon. Anyways, that's for quadratic ax squared plus bx plus c. Alright, in that case, let's keep on moving forward. X squared plus 4x minus 38. So our a is 1, our b is 4, and our c is negative 38. So let's get this started. Negative b is going to be negative 4 plus or minus the square root of 4 squared. So 4 squared is 16 minus 4 times a. So 4 times a is 1. So 4 times a is 1. And then c is negative 38. So 4 times 1 is 4 times negative 38. 4 times negative 38. I'll need my calculator for that one. We'll just adjust it all. 4 times negative 38. Negative 152. So there'll be 16 minus negative 152. So that's 16 plus 152, all over 2a, which is going to be all over 2. So that's going to be negative 4 plus or minus the square root of, what do we do, 16 plus 152, which is 168. And can I take the square root of 168? No, I can't. So that's be plus or minus the square root of 168 all over 2. And at that point, this is an acceptable way to leave the solutions to the quadratic formula. Alright. For number 7, first I have to get everything off to the same side, so I'll have on the left x cubed, then I'll have 9x squared minus 4x squared, because I'm subtracting 4x squared, so it's going to be plus 5x squared. And I'm going to be adding x to each side, so plus x plus 5. And this might seem confusing at first, but I'm going to rearrange this. Normally I would have it arranged in the normal polynomial form in descending order from highest degree to lowest degree, but here I can factor by grouping. So I can factor by grouping. And when I factor by grouping, what I do is I take terms that have common factors that I can take out. So I'm going to rewrite this as x cubed plus x plus 5x squared plus 5. And the reason I do that is because I can group these factors and take out the greatest common factor. So with x cubed plus x, I can take out an x, and I'll have x squared plus 1. And with 5x squared plus 5, I can factor out a 5 and continue to have a an x squared plus 1. So these terms in the inside of the parentheses are the same. So my ultimate factored form of this will be x plus 5 times x squared plus 1. Alright, so that's number 7. Let's go to number 8. So number 8, x to the 5th is equal to 5x minus 4x cubed. So once again, rewrite this with everything on one side. X to the 5th is plus 4x cubed minus 5x is equal to 0. So I'm going to factor out an x because I can. If you can factor anything out of the whole thing, do it. X times x to the 4th plus 4x squared minus 5. And so this takes the quadratic form where I need to have two values. The first two values are going to multiply to x to the 4th, so that's going to be x squared and x squared. And you need to find terms that add to negative 5 and multiply to negative 5 and add to 4. And those I don't know how to say, I just intuitively know that's going to be x squared minus 5. X squared plus 5 and x squared minus 1. Because 5 times negative 1 is negative 5, and 5 minus 1 is 4. Okay, so that's 8. Alright, going to number 9. Alright, use long division to divide 1 plus 4x cubed minus 8x squared by 2x plus 2. So what I'm going to do is I'm going to rearrange the polynomial so that it's in order of descending degree. And I'm going to write this in a very specific way. 4x cubed minus 8x squared, and then plus 0x plus 1. That's our original term, and then our divisor is 2x plus 2. And we're going to do some polynomial long division. So 2x plus 2, what we're going to do, gotta make sure that I'm efficient with my time here. So 2x plus 2, I need to divide my leading term here, which is going to be 2x, by my leading term here, which is 4x cubed. So 4x cubed divided by 2x is going to be 2x squared. So now that I have my term at top, I have to multiply it through. 2x squared times 2x is 4x cubed, and 2x squared times 2 is 4x squared. and I take my two terms and I subtract. So 4x cubed minus 4x cubed is 0, and negative 8x squared minus 4x squared is negative 12x squared. Sorry, and I bring everything else down. Okay, next one is negative 12x squared, and so that'll be minus 6x. The reason why it's minus 6x is that's because minus 6x times 2x is negative 12x squared, and minus 6x times 2 is going to be minus 12x. And so put parentheses around it, subtract negative 12x squared minus negative 12x squared is negative 12x squared plus 12x squared. So that's going to be 0. And 0x minus negative 12x is just going to be 12x. And then I can bring down that 1. And lastly, to get rid of that 12x, I have to do 12x divided by 2x, which is going to be 6. So plus 6. 6 times 2x is 12x. And 6 times 2 is 12, so it'll be 12x plus 12. Subtract 12x minus 12x is 0, and 1 minus 12 is going to be negative 11. And at that point, negative 11, 2x plus 2 can't go into negative 11, so that is our remainder right there. So our final expression will be this term plus the remainder divided by the dividend. So what it would look like 2x squared minus 6x plus 6 minus 11 over 2x plus 2. Okay, that's the problem. That's 9. Let's go to 10. Is x plus 7 a factor of x to the 5th plus 4x to the 4th minus 21x cubed plus 2x plus 14? Show any work that leads you to a conclusion. So what I'm going to do is I'm going to use synthetic division. Use the remainder term. We're going to use the synthetic division. So x plus 7 is our divisor, so that's going to become a, switch the sign, become a negative 7. The coefficients here are 1x to the 5th for x to your 5th term, 4 for our x to the 4th term, negative 21 for our x cubed term, 2x, so that'll be 2 for our, 0, so there's a 0 for x squared term because there's no x squared term, 2 for our x term, and 14 for our constant. So that says constant. Alright, now, for synthetic division, you need to find the remainder to see if it's a factor. Alright, so bring down the 1, 1. 1 times negative 7 is negative 7. 4 plus negative 7 is negative 3. Negative 3 times negative 7 is positive 21. Negative 21 plus 21 is 0. 0 times negative 7 is 0. 0 plus 0 is 0. 0 times negative 7 is 0. 2 plus 0 is 2. And 2 times negative 7 is negative 14. 14 minus 14 is 0. So this last term is the remainder. So using synthetic division, x to the 5th plus 4x to the 4th minus 21x cubed plus 2x plus 14 divided by x plus 7 resulted in a remainder of 0. Therefore, x plus 7 is a factor. Boom. Alright, next page. So, actually for this function, I put in 7x to the 4th power plus 20x plus 20x cubed minus, to do minus 20x squared minus 60x plus 9. Oh, I'm sorry. Plus 20x cubed minus 24x squared minus 60x plus 9. And then I went to our window, hit window, and made my x min -4, my x max 4, my x scale be 1, my y min be -100, my y max is 100, and my y scale would be 1. And I graphed it. And I got the same graph that's kind of seen here. Now, the main thing that I'm going to do is I'm going to use the graph to determine at least one 0. Alright? So I'm going to use the graph to determine at least one 0, and the 0 I'm going to determine is this one right here. Because this one appears to be directly at -3. So that one right here looks like it's pretty much at -3, but I'm going to choose a left bound point and a right bound point, and then my best guess will be right here. And yeah, so there's a 0 at -3, 0. So the 0 is 0 so the point at -3, 0. So if we have a 0 at -3, that means a factor is going to be x plus 3. Because if x plus 3 equals 0, subtract 3 from each side, x is equal to -3. So, that being said, x plus 3 is a factor. So when we do synthetic division, what we can do for the original function is we can do -3. So we'll have -3 right here. And we're doing synthetic division, so we will have 7 for our x fourth term, 20 for our x cubed term, -24 for our x squared term, -60 for our x term, and 9 for our constant. I'm going to use synthetic division. Bring down the 7. 7 times -3 is -21. 20 minus 21 is -1. -1 times -3 is 3. -24 plus 3 is -21. -21 times -3 is going to be positive 63. -60 plus 63 is going to be 9. Sorry, 3, and 3 times -3 is -9. Negative 9 plus negative 9 is 0, okay? So that also shows as a factor. So what we can do is we can factor out that x plus 3, but then this will show us what our new function is. So this becomes the x fourth, the x cubed. So what originally is the x fourth term, the x cubed term, the x squared term, the x term, and the constant. You go one down in degree. So this becomes the x cubed term, 7x cubed minus x squared minus 21x minus 3. Oh, sorry, plus 3. Okay? And then at this point, it's hard to find those exact values, so then I would say at this point, to find the zeros, you just look at the values right here. So you can use your zero function to find the zeros here, and you can find the zeros here, and find the zeros here. You can calc your zeros. And get your values. Alright. So that would be a 0 at negative 1.732 about. But let's keep going. I'll go back to 11 if I have to. So we're going to have to list all the zeros. How much time do I have left? 27 minutes, okay. Of f of x equals x cubed minus 1, given that f of 1 equals 0. That means if f of 1 equals 0, that means that when we, well, that should be the case, that x cubed minus 1. So what we can do is we can just plot the function x cubed minus 1. Graph that. So we see that we have multiple zeros. Let's zoom in. Okay. I'll zoom out. So because this, I mean really all this function is the x cubed graph, but it's minus 1. That might be the only 0. So definitely if graphing this, table, we'll have our table start at 1. We have a 0 at 1, and that's most likely the only 0 for the graph. So all we have is a 0 at x equals 1. So when x equals 1, y equals 0, and that's, I mean, found that via calculator table and also just from the graph. Let me go back to zoom standard. Right, you're going to have, that's the only 0 when you do zoom standard. That's the only 0 you see. So if x equals 1 is a 0, that means that x minus 1 is a factor. So you would have 1 as used in synthetic division. Then for our x cubed term, we'd have a 1, x squared 0, x 0, constant negative 1. Using synthetic division, 1 times 1 is 1, 1, 1, 1, 1, 0. This becomes x squared plus x plus 1. And at that point you would want to factor this, but this won't factor. So you'll have to use a quadratic formula. So that'll be negative 1 plus or minus the square root of 1 squared minus 4 times 1 times 1, so 1 minus 4, all over 2 times 1, so all over 2. So it'll be negative 1 plus or minus the square root of of negative 3, all over 2. So that'll be negative 1/2 plus or minus, that'd be root 3i, because that'd be the square root of 3 times the square root of negative 1. So it'd be plus or minus root 3i over 2. So those would be the other zeros. So that's a 0, and 1 is also a 0. Okay. If 7i minus 6 is 0, list one other 0. So remember, if a plus bi is a 0, then the other 0 would be a minus bi. So if negative 6 plus 7i is a 0, the other 0 would be negative 6 minus 7i. How much time do I have left? 20 minutes remaining. Okay. So this is the other 0 here. These are the two zeros. That's from the fundamental theorem of algebra. And also, if we have root 17 minus 4i, the other 0 would be root 17 plus 4i. So look at that pattern, refer back to your notes. Factor the function x negative x to the 4th minus 4x cubed plus 16x squared plus 64x, and sketch the graph. Zeros and end behaviors are vital. Okay. So we need to factor this. So first I'm going to take out I can take out an x. So I'll have, I can factor out an x and have negative x cubed minus 4x squared plus 16x plus 64. Alright, and what I think what makes the most sense is to factor by grouping. So let's group this term and this term, and if I factor out here a negative x squared, I can have factor this as, and this is just a big bracket right here, this term is negative x squared times x plus 4. And in this case, I could factor out a 16 here and have x plus 4. So this can ultimately factor as x times negative x squared plus 16 times x plus 4. Alright, so now I need to find my zeros and end behavior. So I have 1 0 at 0, so that's 1 0. I have another 0 at negative 4, and if negative x squared minus 16 equals 0, then negative x squared is equal to 16, which means x squared is equal to negative 16, and then that means x is going to be equal to the square root of negative 16 is going to be positive and negative 4i. So those are imaginary zeros, but our leading coefficient is negative, our degree is even, and we'll have a 0 at 0 and a 0 at 1, 2, 3, 4. 1, 2, 3, 4, negative 4. And I know the end behavior is going to be going down on both sides. We have a multiplicity of 1 here, so that's going to pass through, and 1 here that's going to pass through. So a reasonable graph could be something like that. So once again, we have imaginary zeros here, so we don't have to worry about it. And that's for finding imaginary zeros stemming from that term. I only calculated those right there. So that's 15. Time 15 minutes. So let's go up to 16, 17. So we need to find the positive, negative, real zeros. We do that for find the sign changes. So we go from 3x6 to 7x squared. So for f of x we have no sign changes, 1 sign change, 2 sign changes. So there's 2 positive, excuse me. So we have 2 possible positive real zeros. Real zeros. Let me just write zeros. And then to find negative sign changes, we'll need to find f of negative x. F of negative x is equal to, so x to the 6th, it'll still be 3x squared x to the 6th. But then you change the sign for the 7 for the even terms, so it'll be minus 7x cubed plus 2x minus 6. So then we go from 3 to negative 7, so that's 1 sign change. Negative 7 to 2, so that's 2 sign changes. Alright, sorry, I'm going to stop right now, plug in my cord, and then resume the recording. So I go from negative 7 to positive 2, that's 2 sign changes, and you go from positive 2 to negative 6, that's 3 sign changes. So I have 2 possible positive real zeros, and I have 3 possible negative real zeros. RE real zeros. Okay, so that's 16. Let's go to 17. H of x is equal to 5x to the 6 plus 2x cubed minus 36x minus 9. Okay. So, same deal. 5 to 2, still positive, and 2x cubed, so 2 to negative 36, so that's one sign change, 0 sign changes. Negative 36 and negative 9, that's still one sign change. So negative 36 and negative 9, no sign changes there. So you still have one sign change. So I have one possible positive real zero. So that's one possible. Impossible. Then for f of negative x, that's equal to 5x to the 6 plus 2x cubed minus 36x minus 9. So that'll be 5x to the 6, that's the even degree, so minus 2x cubed minus 36x plus 36x minus 9. So look at the sign changes. 5 to negative 2, that's one sign change. Negative 2 to positive 36, that's two sign changes. Positive 36 and negative 9, that's three sign changes. So we have three possible negative real zeros. Okay. Now we go look at 18. Given the graph of g of x, identify the following local minimum values. Okay. So local minimum values looks like we have a local minimum right here, more or less, and a local, that's when we go over increasing, decreasing, and then a local minimum right here, more or less. So we have those values, okay? So I've marked those on the graph. Local maximum values, when we go from decreasing to increasing, have a value right there and right there. So let's see if we can plot those points. Local max, we have values at 0, 0. That's this point right here, and 1, 2, 3, 4, 5, 1, 0, 0, and 5, 1. For local minimums, it looks like we have a value at 1, 2, 1. That's like almost a little bit past 1, so it looks like we have local min at like 2, negative 1.2. And we also looks like we have a local min at 1, 2, like 2.3, and 1, 2, it's like also 2.3. So we also have a local minimum at negative 2.3, negative 2.3. And that's just guesstimating looking at the points on the graph. Alright, the minimum degree. Alright, so how would we find the degree, the minimum degree? What we can do is we can look at our zeros. So so first of all, we have to look at our zeros and we have to determine the multiplicity. So we have a 0 right here, and that passes through. So that's at least an odd degree pass through. So for minimum degree to pass through, so I'm going to have to go in between the graph and to find the minimum degree here. Okay. So our minimum degree, first zero right here, passed through. So that's at least a x to the 1 term. Okay? Then we have another 0 right here that bounces. So that's at least an x squared term, an even degree. Then this 0 right here passes through, so that's at least an x to the 1 degree. And this 0 right here passes through, so that's also at least an x to the 1 degree. So x to the 1 times x to the 1 times x to the 1 is x cubed times x squared is x to the 5th. So our minimum degree is 5. And that's because that's a pass through. That's for that 0, that 0, and that 0. And that 0 right here bounces. Okay? The sign of the leading coefficient. So this one has the opposite end behavior of your normal odd degree. So the sign of the leading coefficient has to be negative. So this has the end behavior of a odd degree negative leading coefficient. Write a possible function from the graph, leave it in factored form. So that a 0 right here is 1, 2, 3, 4, 5. So that would be x plus 5, let's say to the first power, because that passes through. And then the next 0 is at 0, so that's going to be times x squared, because that has to pass through. Then we have another 0 at 1, 2, 3, 4. So it would be x minus 4, and that passes through, so to the first power. And that next 0 is going to be 5, 6, x minus 6 to the first power. Alright, so that's a possible function. Alright, 19. Scientists and fishermen often estimate the weight of a fish from its length. The data in the table give the average weight of a North American sturgeon for certain lengths. Because weight is associated with volume, which involves 3 dimensions, we might expect that weight would be associated with the cube of the length. So for 19, find the cubic model from the data. Then, so that's A. B, use the model to estimate the length of sturgeon 56 inches. Compare the weight with sturgeon length of 44 inches given by table 1 with the weight given by the model. Okay? So we'll need a calculator to do this, and we're going to need to input values into the table. So in order to input values to the table, I go to Stat, Edit, and I input the length, our input, into these x values. As you can see here, I can change it just by changing. So let's say that's 58, and that becomes 58. But really, remember that value is 60. Then, for weight, I plug in 13, 26, 46, 75, 115, 166, 282, 492, 796. Alright. So I plug in the table values, and then go back to Stat. I go to Calc, and he wants me to find a cubic model. To find a cubic model, I'll do a cubic regression. And yes, I want my x list to be the first column, my y list to be the second column. Let me calculate. And so in the form ax cubed plus bx squared plus cx plus d, a will be 0.053, b will be negative 0.117, c will be 1.423, and d will be negative 5.004. So the cubic model, we can approximate that, but the cubic model would be 0.117 0, 0, 5, 3 x cubed plus, so actually that would be minus, so sorry. So actually, because I already wrote this in pen, plus negative 1.17, so sorry, 0.117 x squared plus 1.425 x minus 5.004. And now that I have that in my calculator, to estimate the length of a sturgeon at 56 inches, it would ultimately be easier to just, for our function, find a value of 0.0053 x cubed minus 0.117 x squared plus 1.425 x minus 5.004. And so that's going to be the function. I'm going to go to my table set. I'm going to start my table at 56. So if x is 56, y is 638.65. So using second table, graphing the estimate, graphing regression, when x equals 56, y is going to be equal to, that's 638.65. $638.65. Alright. Now C, compare the weight of a sturgeon for a length of 44 inches as given by table 1 with the weight given by the model. So that's saying if x is 44, so I'm going to go to 56, I'll go scroll up to 44. The model says that for the model, when x equals 44, y is equal to 282.66. Y equals 282.66. And then what the data says, that's what the model says, what the data says is that when x equals 44, y equals 282. It says when x equals 44, y equals 282. So it's a pretty accurate model. Alright. Number 20. Sketch freehand a graph of the function f that satisfies all the following conditions. F of negative 2 equals negative 4. So when x equals negative 2, f of x equals negative 4. 1, 2, 3, 4. So make sure the graph contains that point. Negative 2, negative 4. X minus 5 is a factor of f of x and is multiplicity of 7. So that means that we have a 0 at 5. 1, 2, 3, 4, 5. And the factor will pass through at that point. the leading x squared is a factor of f of x. So I'm going to get to C in a second. So that means that x squared, that means the zero, you're going to have a 0 at 0. Because if x squared is a factor, you have a factor, it's going to have a 0 at 0. And that's going to pass through, that's going to bounce, unlike here where it passes through. And f of x is even. So if you have an even and a positive leading coefficient, you're going to have end behavior that when x approaches negative infinity, x approaches infinity, and x approaches negative infinity, f of x approaches infinity. So you get end behavior that looks like this. So our end behavior is going to look like this. And this will satisfy all the following equations. If we go here, bounce, and then at this point we pass through and go up. Alright, so that's a potential way to draw it. It just needs to satisfy A, B, C, D, and E. It could look completely different, but that just goes through all these, meets these conditions. Alright. Number 21. A rectangular container measuring 1 foot by 2 feet by 4 feet is covered in a layer of lead shielding of uniform thickness. So look at the figure. Find the volume of the shielding V as a function of the thickness x in feet of the shielding. Okay? So what you have is a box with dimensions and then a shielding x units away covering the box. So if we're supposed to find the volume of the box, so the volume of the box is equal to 1 times 2 times 4, and those are feet. It's going to be equal to 8 feet cubed, okay? And the volume of the lead shielding is going to be, in each direction you have increased lead shielding. You can look at it on your own paper by plus x. So that's going to be plus x in that left direction and plus x in the right direction. So because of that, we have plus x and plus x. So we'll have that's feet cubed, by the way. So when their volume is 8, the volume of the total box with shielding minus the volume of the box is going to be 1 plus 2x, because the length is going to be the original length plus 2x in each direction, times 2 plus 2x, because you have the width in each direction, times 4 plus 2x minus 8, which is the volume of the original box. So now we need to do some algebra, FOIL this out. So this becomes 2 plus 2x plus 2x plus 4x squared. So that's multiplying the first two terms. And we multiply this term by 4 plus 2x, which is going to be equal to 2 times 4 is 8 plus 8x plus 8 plus 8x plus 8x plus 4x squared, so plus 16x squared. And so then if you're multiplying everything by 4, we'll multiply everything 2x plus 2 times 2x is plus 4x. 2x times 2 is 4x plus 4x squared plus 4x squared, and then 2x times 4x squared is plus 8x cubed plus 8x cubed. Alright, so that's a lot of terms. That's ultimately going to be 8x cubed. Now we're going to look at my x squared term. So 16x squared plus 4x squared plus 4x squared is going to be 16x squared plus 8x squared. So 8x cubed plus 24x squared. 8x plus 8x is 16x plus 4x is 20x plus 20x. And then we have 8 and then plus 8. So we have 8x cubed minus 24 plus 24x squared plus 20x plus 8, and then we have that minus 8 at the end, minus 8. So those 8's cancel out, and the volume of the shield will be 8x cubed plus 24x squared plus 20x. I'm going to factor a 4x. So if I factor a 4x, I'll have 2x squared plus 6x plus 5. And let's see if I can factor this. So I can factor this as 4x times 2x squared. That'll be 2x and x. And then to get 5, I just need 5 and 1. So no, that wouldn't work. So I'll just leave it the way it is. So that's the most factor I can do. Find the volume of the lead shielding if the thickness of the shield is 0.05 feet. So I'll have 8x cubed plus 24x squared plus 20x. So to find that volume, I'm just going to plug that into my calculator. 8 sorry, I want to make sure that you can see it. It was working. So I'm trying to get it so you can see everything in your calculator. So y1 is equal to 8x cubed plus 24x squared plus 20x. Alright, I'm going to second table. I'm going to go to, so the first thing I'm going to do is go to second table set. And my table start at 0.05, and I'm going to have my change in table be 0.01. So going to the second table. At 0.05, the volume is going to be 1.061. So y should be equal to 1.061. Alright, that's the entire video. Or if you don't, have a great day.